Right, well, today's going to be a pretty interesting day. We're going to go over a design pattern that's not technically a design pattern on Refactoring Guru, but is very useful and very commonly used. In fact, I ripped this set of slides directly from software engineering because it's something that we do in software engineering that I go over right before you actually implement it. But I figure I will go over it in 212 because I don't know who is taking 350 next quarter versus next year. If it's next quarter, I honestly have no idea what's going to happen. But if it is next year, then you will probably see this exact set of slides again, right before you implement it in software engineering. In fact, it's so ripped from 350 that there we go. It says 350 on it. But it's something that you should absolutely see at some point in your undergraduate education, regardless. And it's something that is complex enough that you probably want to see it a couple of times before you have to implement it anyway. So I think this will just be useful to people in general. And I figured this is something that I could tack on at the end of the course after we covered most of the relevant and important design patterns. I'm still planning to, something like tomorrow, just go through Refactoring Guru for all of the design patterns that we haven't covered, just to give you a very basic overview of what is the pattern. I won't throw any of those on the exam in any capacity, so you don't need to know them at a technical level. You're not going to get experience with them, but I think it's good to know what they are and what they do so that you can associate the name when you hear them, or if you see something in the future that is a problem that that design pattern would cover, that could be useful. That said, I reserve the right to throw Model View Controller on there, at least at a high level. You won't get experience working with it, but at a what is it level, it may appear on the final. My goal is to get a study guide to you by end of day tomorrow to give you just about a week, little over a week before we have the final in the class to look over that. Monday's class will be a review session. I'll field any questions that people have. I won't have any content designed for Monday, so I will be relying on all of you to come with questions. If students don't have questions, I'm gonna look silly up here, very bored, stammering for something useful to say, kind of like I'm doing right now. So come with questions, please, and then I can make sure that people answer them, because we learn a lot from each other's questions. Any questions or concerns before we get started? Okay, Model View Controller. Has anyone heard of Model View Controller before or know what that is a little bit? When will the new lab be posted? It should be up now. Have people seen the new lab? That's something that's worth just figuring out right now, because that's a very important thing.
I also did not see it.
Hmm.
We remain unseen.
Yeah, I don't know what happened there. I will diagnose that immediately. Thought I threw it up yesterday. Yep, it's not visible. I hate Canvas as default. Now it is. I apologize for that. I meant for you to be able to start that yesterday. But now it is visible. Now you can get started with it. I do apologize for that. But I think I can't push it back any more than Monday, because maybe I could. We'll see how it goes. I think this one should be easy enough that it should be doable within the time frame. But I will remain open if your other classes are crunching you. I'll remain open to potentially extending that on an as-needed basis, also depending on what the grader's backlog looks like at the time. I don't like things being due during finals though, so we'll try to avoid it if possible. All right, Model View Controller is a design pattern, even though it's not frequently relayed as a design pattern, but it's very useful when you have an application that stores data in some sense, and you need to separate the data that is being stored from the user interface. We've talked a little bit about some design patterns that are useful for that, when we had the weather station storing its data, and then we tried to grab that from there as well. But this would be if you actually have access to the data yourself, you're not pulling it from some external location. So we can have an app that does a bunch of different things. It can load and store data. It can construct and display a user interface, and it also needs the ability to, in real time, interpret user actions. So if you click on something in the user interface, what do you do in order to prepare and change the user interface or prepare and change the data? Because those are going to be happening in parallel. The data that you need to store and modify is going to be different from related to the changes in the user interface based on the interaction that the user gave. So they are largely independent of each other, right? You make a change and the UI updating doesn't affect the data. The data updating doesn't affect the UI. So we need one task for each of what we're going to call the model, the view, and the controller, which is what MVC stands for. The model has everything to do with data. So any methods that you write or classes that you write that have to do with storing and retrieving data. So questions that you might ask that are related to the model is, which database table is the requested data stored in? If you have a large set of tables associated with it, what SQL query will give me the data I need? For those of you who haven't taken a databases course, you will become very familiar with SQL as you take a databases course. But trying to figure out what associated query would get you the data that you need to be able to parse that data, that is something that the model would be responsible for. The view, on the other hand, is everything to do with the user interface. So the user interface queries the model and says, what is the current state of the data? It interprets that feedback from the model in a visual way to be able to display the result of that data in a way that is user-friendly, in a way that someone can look at the user interface and say, I understand the state of the application. So the model, the view, is responsible for things like text color, placement of all text, placement of data, whether we have a drop-down list, radio buttons, anything of the sort that has to do with how that data is displayed, that is the view's responsibility. Finally, we have the controller. The controller is a sequence of listeners. They're waiting for the user to interact with the view in some way. When that happens, a request is sent to the controller for some kind of parsing of lines of what are we going to do when the user does something to the view. So it's just a sequence of listeners. So the user clicked the hide details button. The view needs to know that the user clicked that so that the view can update and hide the details. The user just changed the event details. The model needs to know that the data should be changed because the user did something. You can imagine a calendar app where there's an event that maybe you moved from 2 o'clock to 3 o'clock on a particular day. And if you do that, then the data needs to be changed. The internal data that knows when that event is happening needs to be changed because the user changed something in the user interface. So you can see that the controller is kind of sitting and waiting for user input. When it does, it triggers the associated code that makes the change to either the model or the view. Questions about any of these components? No questions about model or view or controller? Why would we care to do this? As usual, we have, if we can split the actual code up into these 3 components, we have better code organization. It's easily maintainable. If you know that you need to make changes to the data model, you know to only look up the model code. If you want to make changes to how the listener handles user input, you know to look at the controller code. You look at the view if you want to change how the data that's being displayed is actually displayed. Ease of development, this means that you can test each of these components independently of each other. So you can test different views associated with the project. You also get flexibility, just like we've seen, we get kind of the extendability of the ability to program a new view. So you could have a desktop view and a mobile view of the same data. And then you could swap them in and out on demand. And nothing about the model or the controller would change. Theoretically, we have this view of these three components. So the controller talks to everything and receives information from everything. The view talks to the controller and receives information from the model, and the model pushes changes to the view and is able to communicate with the controller back and forth. There's no reason for the view to directly change the model. That would have to come through the controller when the user does something. The controller would recognize that the user did something and communicate the associated changes to the model. So there's no reason for the view to communicate directly with the model. It would have to go through the recognition that the user did something. So that's in theory. In practice, we find that the user interface and the listeners that are waiting for changes for the user to interact with the user interface are so coupled together that they usually occur, like you have a certain view component, and when the user interacts with that particular view component, then there's logic associated with the changes that happen. So the view and the controller are very coupled together, and there's kind of a method for, here's a button, here's the logic that happens when that button is pressed. Here is a drop-down menu, here is how the view changes when the drop-down menu is clicked. So they're usually, in practice, very coupled together. So in reality, it looks a bit more like this. The view and the controller may actually be in the same file for each of these objects. And the model will update the view controller pair and communicate with the view controller pair. Questions on the concept of how those might be coupled together or not? We've seen this once before at this point, talking about one design pattern. I actually forget which one it was, but we actually have a design choice when it comes to how the model is prepared. Either was when we did the weather data as well, when we can either push information from the model, so data changes, we need to tell the view that data has been changed, you should update yourself. So that's the concept of push. The concept of pull would say every so often the view wants to update, so it's going to give a request to the model to update. So that request would go find the model and say, has anything changed? If so, give me the new data so I can update myself. So that's a push versus a pull architecture. Does the model push the data to the view, or does the view go pull the data from the model? Who's responsible for that change? It's either the model or it's the view. If it's the model, then you have a push architecture. If it's the view, then you have a pull architecture. So push says as soon as the model changes, it notifies every view of those changes, and each view is capable of updating itself based on the new data. The pull says when a view needs to be updated for some reason, it asks the model for data and updates itself accordingly. Why would you choose to use one or the other? If it's push, you always know at every point in time you have the most up-to-date data. Because if something changes, then the model is going to push that data to all the views. So at any point in time, you are looking at the most up-to-date data. Great. For pull though, you don't have to update quite as frequently. If the data is changing every second, that's a lot of computation power that's going into updating this. It may not be necessary to have a second by second update of the weather. If you're looking at the weather app, you don't want to be seeing today's high is 52, 51, 52, 52, 51, 52, 53, 52. It's not useful. If you look at it and 52 is close enough to 51 or 53, you only maybe need to update that once every half hour, once every hour with the newest changes, because it's not likely to change by more than a degree or two, which isn't going to change exactly how you interface with the weather. So maybe a pull architecture makes more sense there, so you're not looking at something that gives you some kind of, I don't know, what's the flashy? I can't think of words today.
Strobe.
Yeah, some kind of strobing effect. So you end up with a seizure from the strobing effect because the temperature is changing so frequently that computers work fast. Our brains don't work as fast as computers do. So if it's updating so frequently that you get a strobe effect and then you end up with a seizure from looking at an app, that's not great. So that might be completely useless. Let's take a look at an example of model view controller in practice. So we're going to look at a traffic signal. You can imagine writing a program for a traffic signal. It's going to have a few components. Some of these components belong in either the model or the view or the controller. So let's take a few moments, talk to whomever is sitting closest to you or not if you hate their guts, and figure out where each of these components, whether they should go in the model or the view or the controller, and come up with some reasoning as to why. And in a few minutes, we will go over this. Calvin says, sorry, Carson.
It's okay.
You can work in groups of larger than 2 as well if you'd like.
That's cool. Okay.
You brain no longer functioning exception, that would be a great exception to write in the program.
It's some stuff. It's great to stop responding. Flick away. Maybe it's far. Maybe it's. But then you will be responsible for. That applies to the road. Yeah, the pedestrians.
I mean, it's not wrong to like go to the and be big for a modern day and go and try to on day
So. But yeah, that's kind of. I see. Did traffic lights that have a car enter the waiting area, because that also has to change that. I guess it depends on the, but. That one car that's, I'm never thinking, but it's really the length. That makes sense.
So like signals direct.
Yeah. This is the.
Yeah, I think that should change.
Yeah, so I think those are gonna go. Model and controller.
Maybe that'll be fine.
Good one. So,
Yeah. They all work. Certain time which trigger changes. I think that's the controller. I think that's a part.
Yeah.
Which one? Very possible. External.
Yeah, so like I think of this student model and controller, file and controller. Signals. Go into view. Regulate the valid chat. Also. If we say that, and how.
Yeah.
Supposed to do. Yeah, that's very true. I mean, the-
The most sense to do the detection. In the model. And then.
No.
You get start.
That's probably one of those things.
Regulate trigger traffic movements. It made the manual. And control it.
So I was wondering if
And
you
then
might
the signals for the lights.
like this, like,
Set.
set.
Think we have some answers?
We have some guesses.
Looks like we have some guesses in Zoom as well, so I will. I'm curious what people think. I'm gonna start writing, if you're sure, I'm gonna write an X. If you're not quite as sure, I'm gonna write question marks. So what do we think? For number one, detecting cars waiting to enter the intersection, where should we put that? Controller? Agreement, disagreement?
I wanna say model.
All right, we have a couple in Zoom as well that also say model, so I'm gonna put question marks here between controller, model. It's probably not the view, so this is good. It's one or the other of the non-user interface places, but no, this is probably honestly the most challenging one to place. So I think that it's good that we're starting there, and it's also good that we have some disagreement. How about the traffic light to direct the car traffic? View, I think there's a pretty good consensus that this belongs in the view. So I'm gonna put an X there that says, we're reasonably sure that that belongs in the view. How about regulating valid traffic movements?
Take that one.
That should be.
Controller?
I see. Controller.
What did you get?
Controller.
I mean,
I don't.
Models? All right, we're gonna figure out,
Isn't that?
we're in one of these two.
But that's.
How about a manual override for a particular light? Where does a manual override go?
Because it's. detecting cars.
Controller?
That should be a control.
Controller? All right, we're gonna make an educated guess that this belongs on the controller. Detecting pedestrians waiting to cross.
That share the same thing as detecting cars. For me, I would say.
Whatever this is, this should also be that,
Yeah,
maybe?
Yeah.
they share the same, the same kind of logic.
Sure. So if we were unsure about this, are we unsure about this, or do we want to try to break this uncertainty with figuring out pedestrians waiting to cross?
I'm sticking to my guns. I'm sticking to controller.
Think it's controller?
I say it's controlled because it also,
Wait a second, wait.
the data is getting
We did.
inputted.
I'm gonna leave this as,
Uncertain.
that is okay, that means that there's a learning outcome still to come. I'm okay with that. How about pedestrian signals?
That's beautiful. That's solid.
Alright, we know when it's the view, excellent. How about an external timer that triggers changes at a particular set interval?
That's behavior should be. It's a structure. I said mom.
Model,
I think we said.
I think model.
model. Let's see, was there? Oh, nope, someone on Zoom said controller, so we're going to. We're kind of uncertain about things, that's okay. Are we ready for the answers?
Bring it on.
Bring it.
You're wrong.
We weren't horribly wrong about any of these, but sometimes when we said we don't know, the answer was controller, and sometimes when we said we don't know, the answer was model. So let's figure out the actual difference between this so that we can understand this ambiguity. So whenever we see an action word, first of all, let's try to model is associated with data. I'm just gonna kind of put data up here. View is UI, and controller I'm gonna associate with a word that we're gonna call listener. It's waiting for something to happen so that it can make some kind of decision. What it does with that decision is up to either the model or the view. The controller doesn't actually handle any of that logic, but it's waiting to notify either the model or the view that something has changed. So detecting cars waiting to enter the intersection, this is a controller. And the reason it's a controller is it's a listener. It doesn't handle the logic of what happens when a car enters the intersection, but if a car has entered the intersection, it needs to notify the model that there are cars waiting at the intersection. And then the model can figure out, when do I change the light? Based on the number of cars that are waiting at the intersection, or whether there even is a car waiting at the intersection. We got the traffic lights, that's obviously a UI thing. Regulating valid traffic movements. This is data. Whatever a valid traffic movement is needs to be stored somewhere so that we know whether or not something is actually legal or not. So that would be stored in the data. A manual override for a light, someone that's gonna wait to change something, that's a listener. That's something that's always online and waiting for that override button to be pressed. If that override button is pressed, then it will notify the traffic light to change. So it would notify the view that it needs to be updated, or it would notify the model that the current direction of flow of traffic is changing. So that would be a listener. Detecting pedestrians waiting to cross, that's that keyword detect again, which means that we're waiting. We're sitting there listening, waiting for a pedestrian to hit the button. When it hits the button, we know that a pedestrian is waiting to cross. The controller, once again, is not trying to handle that logic, but it will pass along that knowledge to either the model and or the view to say something, this might change what we do. So the underlying data that says we're waiting for someone to cross this direction, that would be an important data update to do in the model. And for the UI, we would want to make sure that we set something that says when the next light changes, maybe we also display the walk sign. Note that not every time a light changes, the walk sign is on. That's the case at major intersections, sure, but maybe your system does not display the walk sign unless there's actually someone who's waiting to cross the street. We got the pedestrian signals, but the external timer to trigger changes at a set interval, that's a listener. We're waiting for that timer to hit 0. Once that timer hits 0, we're gonna send a signal to the model and or the view that says it's now time to change the direction of the flow of traffic if it's a timed light. Does all that make sense? So there is a good bit of confusion, I think, between the model and the controller, but I'm hoping that this discussion has done some work to clear that up. So we have data, UI, and listeners, and that is the important way to know the difference. So if we were looking at what each of these components would actually be responsible for when we did this, the model would be storing things like the current state of the traffic flow. Which direction is the traffic currently flowing? Which lights are green, which lights are red? So it knows the current direction of traffic, and it's also capable of skipping a light cycle. If nobody is waiting to cross the other way, why would you turn the light that traffic is actually going through red so that nobody could go? I've been at those intersections, they are infuriating. Billings is full of them. Truly evil city. I say this from experience, truly evil city. Stores whether there are cars and or pedestrians waiting to cross the intersection so that it knows, is it worth changing the flow of traffic? How long should it wait to change the flow of traffic? The view is all of the information that is being displayed for either pedestrians or cars. So all of the lights, all of the crosswalks, all of that information is in the view. The controller needs to know the current state of the model. It needs to know which direction things are flowing, so it knows that. And it also has all of the associated listeners that tells the model that the state of the data needs to change. If you were to write classes for this, think about what classes you might write within the model or the view or the controller. This is a fun activity as well. Go ahead and in small groups, think of the names of classes that you would write. How many classes would you need to be able to do this associated logic? What if this is an actual class? What if this is an actual method within a class? How many classes do we need for this?
Really, more specifically, the back, this is the
Yeah.
Yeah. That as you are. Observe pattern. So many objects, everything that needs to be controller tabs. I will have a listener that drives and triggers all the behavior for all the classes like provides roles detection.
Yeah, like it's sort of a main class.
Yeah, like
from our other piece.
Right.
It's for all the lights. Well, it's gonna need more than that, 'cause it's like, if you see like your break, so we have those with the power checks, but then now it's just what the right checks are going to do with the controller and then, right? So what this instead just stores, it's like different applications. Well, the class on this shit, so then this other class on ball, which is less than the other subject, was the first. Yeah, so it's model class with subclass, which is an object state. Triggering and state of those things are
We just do
Yeah.
one intersection.
basically sort of
Intersection. Or
so that will be.
that way you check like, is occupied or something for each round. But that's what we figure.
So we just gave this next one. That should show, it's just like, oh. Because that's gonna be-
Oh, wow.
What do we think? How many classes did we come up with?
For model, we had like a super class of like intersection with the subclasses of each one of the north,
Okay,
east, west, south, and then maybe the direction class. A walk lane too for each one of those. I don't know, it wasn't very good. But that way you can check like each intersection was its own class, you can check whether if it was full or
Okay.
occupied.
interesting idea. There's no one right answer to this, so you could create any number of possible designs for this. How many classes are in the view?
You have a class for the, I don't know what any of these are called, the walk signal for pedestrians.
Yeah, it's like the pedestrian signal.
And then a class for traffic lights.
Yeah, okay, sure. That's exactly what I have. So view has 2 classes. How about the controller?
I mean, at least one class for triggers, right? Because then it's like, if this should happen, then I'm gonna send a message to model
Right.
to change something. And then, honestly, I would just have like a field or object inside that controller class that would just maintain what's going on in the model.
Okay. My solution has a single class for the model, 2 classes for the view, and 4 classes for the controller. Let's take a look at what this is. So the model really just needs to store the internal representation. So you could have a field for the direction of traffic. You could have arrays basically of which walk signals are on, which lights are which colors. So you could have an easy lookup for the current state and store that as an object. And then the traffic model object would be the current state of the light. Or the entire traffic situation. For the view, we talked perfectly about having a car light and a pedestrian light. For the controller, each one of these messages should be encapsulated in their own object. So we need something like a pedestrian button object that we can pass along to the model or to the view that tells us when we have a listener, it'll create an object that says like this button was pressed and send that on to the model and the view, each of which have methods for taking in that object and applying. A car detector, we talked about the necessity of if a car pulls up, then we have a listener that's listening for that. So we would need some class that creates that object and passes that along. Same thing for a light switch, is able to enable or disable the light. So that the red light is on or off. If the light is green, then the red light is off and the green light is on. So we would have for each light be able to turn on and off each color of light. And then the timer for figuring out when to switch the light cycle. And each of these should be in their own separate classes because they each have their own separate listeners. And each of those listeners want you to create a different kind of object to communicate that information. You could put all of that in one class, but then it would start to get confusing between when do each of these listeners trigger, what do they do? Putting them in their own classes differentiates each one of them as a separate thing that is being listened for. And you can describe the logic of how to handle each one of those in that class. Again, this is not the only solution to this. There are other valid solutions, but I think there's a bit to learn from just the design, the overall design of how you would structure this. Anyone have any questions on the design of some traffic signal? How to handle any of this? All right, that's everything I have with regards to MVC. So I guess we end class a bit early unless anyone has any questions or something that you would like me to talk about or do for the next few minutes. All right, and we'll come back tomorrow and we will spend tomorrow's class going over some of the patterns that we didn't cover in class, just very briefly on Refactory Guru. And then I can also field questions related to studying for the final, the observer lab that has finally been posted. Again, I apologize about that.
There, TA going in that?
He should be in today, I think. I will actually have to head out, but I think the plan is for him to be in today. And also tomorrow, hopefully as well. So you're able to talk about any of your grade discrepancies. If he had issues getting your code to compile, he can see it running on your machine and at least give you significant credit for that. All right, I will see you all tomorrow.
Sweet, thank you.
Thank you.